Assalamualaikum and very good morning, good afternoon. Boleh dengar?
Waalaikumsalam. Boleh Dr.
Alright. I'm not sure, is there any international student here? Perhaps from Iran or Israel? Nobody? Oh, I know there are a couple of German students just joined us. I'm not sure whether he's taking this class or some other classes. Anywho, how are you guys doing? Puasa okay?
Alhamdulillah Dr. Okay.
Alhamdulillah. Okay, so welcome back to UTM. Even though we are just a few days away from Ideal Fitri, but I guess we got to do what we got to do. Apalah kita buatlah apa yang kita mampu. I guess the first 2 weeks we do not have to rush too much. So for you guys, the class for section 6 will be today and also Khamis. The thing is for this week only, I will be teaching master's class, so that will be Tuesday and Thursday. So meaning I cannot have classes, undergraduate classes for Tuesday and Thursday for this week only. So for classes on those 2 days, I will replace with pre-recorded YouTube lectures from the past. Ada banyak himpunan video-video lama zaman COVID. Semua sihat tak ada kena COVID. Belum ramai ni. Mungkin ada yang tidur tengah hari. Saya pun mau bangkit kan. Anyway, let's move on. So let me share my screen. Oh, ni pun dah lama tak buat kelas online. It's been a while. Share entire screen. Alright, hope you can see. Yes, before we jump into the content of the lecture for today, let's take a look at the teaching plan. Okay, but this teaching plan is not the official one. Official one is not in this format, but I guess the content are pretty much the same. So we have several learning outcomes. The first one will be to identify fundamental principles in problem solving, programming techniques, and structures in program development. Okay, and then to be able to explain principles of problem solving, programming techniques. And then the third one is to construct computer programs codes by applying suitable programming structure and techniques. Okay, but in short, you are expected to be able to do computer programming, and unfortunately, for the test part, you have to show your ability to program without the computer. So you have to write the codes on piece of paper. So that is challenging. I guess when I took this class long time ago, it was like that. But that time I had to. We were taught Fortran and also Pascal. So this time around, you guys are using C++. C++. So for assessment, you have a test. Test will have 2 questions, and then you have a lab report. So this is we have a bunch of tests, in-class tests. But this one will do when you get back to campus, where you can be tested in the computer lab. Then we also have mid-semester. So this is a 2-question mid-semester mid-semester test, and also the final exam. There'll be 3 questions. Okay, so good. So the rest of this, I guess I already shared this in the ULearn. So we'll try to follow as much as possible, as close as possible, and I will see where we can get for this first 2 weeks. First 2 weeks, hopefully we can cover, because especially when we want to get to pseudocode and flowchart, that is very important to cover, because those will come out in the test, mid-semester test. So I guess last semester some of the students said they did not get enough exposure to this kind of things before the test. All right, any question so far? Ada question? Tak ada. Kalau kita let's start on our first lecture. So previously, this class usually taught by a faculty member from FTMK, which is the faculty for IT. But I guess ever since about a year ago, they started to ask our own faculty members to teach this to our students. So that's why you got me and several others from our faculty, from our department, teaching this. So, but we'll try our best to impart this knowledge, and it's not just knowledge, but it's also from your part. Is something that you have to do in order for you to understand, and it is a skill, just like cooking. If you just listen, listen to or watch Harold Aming's videos, doesn't mean that you can cook like Harold Aming. So you have to do it in order to achieve it. So, all right, enough chit chat. Is something you can read by yourself. Why programming? Why programming? Program. So here, the spelling for program in Malay is like this, and also in US English is like this. No ME at the back. But for British English, they will have ME at the back. PROGRAMME. I think so. That's the situation usually. But for us, I think we are going to stick with American English, because a lot of this stuff are usually from America. Like even if you have things like color, in the programming, they will use the US spelling, COLOR, not COLOUR. Okay, so that's the situation. So computer programmable machine design. Okay, semua boleh dengar? Are you following? For some reason, if you have any problem like the display is not showing, please let me know. Hello, is there anybody there?
Yes, sir.
Boleh
Boleh?
dengar.
Okay. So, tengah masak tu. Tengah masak tu apa? Tengah makan. Not for those who are fasting lah. Alright. So computer is the machine. Machine. So I remember when I was doing my PhD, my professor said, "Okay, let's have a meeting. Bring your machine." So machine apa pula ni? Apa maknanya komputer lah. Bring your laptop lah. So the machine, that laptop, your portable tablet or something like that, iPad, iPhone, all those are your machine that can be used for programming. And program is a set of instruction for a computer to follow. So it's like I can give you instruction by oral or by written information, but for computer they need to understand us. We cannot just speak to it. Even though nowadays there are some voice activation available, but actually there are some tools that translate it into something that the machine can understand. So the voice itself is not something they can understand directly. They have something in between that translate it. So even the program, we express it in a language that computer can understand, but actually the language that we use, computer language that we use, is somewhere in between. So we give some instruction using C++ or C or some other computer language, but there is some black box in between that translate it back into what really the computer can understand. Because maybe you have learned or heard that computer, they receive the instruction in zeros and ones. So we cannot write our instruction in zeros and one. I guess for most of us that will be very difficult to do. So we have this computer programming language, which is not Bahasa Melayu, not really English. It's not really Bahasa Yahudi ke, but it's somewhere in between. It's not really human language, but it's not really machine language either. All right, and then the person who does this this programming, the code, is called the programmer. So basically, we are trying to turn you guys into a programmer. Okay, programmer for not really, maybe it's not something that you'll do for for a lot of your career, but maybe a little bit. You have to do a little bit of programming from time to time. Okay, so without programmer, no program. Without program, a computer cannot do anything. So it's something that we need to have in order for the computer to understand what we want it to do. Okay. In this diagram, we have the program goes together with the data. and then gets into the computer, and then we get some output. So it's harmonizing the program and also the data into the computer so that the computer will get some output that we want. Like playing games, there are some ready program, preloaded program in the application, and then the data might be something like your input. You want the character to go left or right. So all this thing must converge into the computer, and then you'll see the output of how your GTA character or something like that will perform in the game. Computer is an electronic device with two major components. So computer refers to both, or consists of two parts, hardware and also software. So we have only the hardware without the software, so it's not usable. Again, if you have software but cannot have hardware that to run it, so it's not useful either. Okay, and then the hardware refers to physical parts of the computer. So basically that consists of memory, or primary storage, internal memory. So many types of memory are available for computer nowadays. Now, not only on the physical computer, but can also be cloud. Nowadays, we can store it in the cloud, or some either international cloud, or maybe you have your own centralized memory or storage for your organization. Then you have central processing unit. So each machine will have their own CPUs. And then secondary storage, external memory, input devices such as touch screen, mouse, touchpad, and all sort of things, even the keyboard, and also the output devices such as your screen, monitors, maybe sound system, printer. So all those things are output devices. Okay, so these are some figures to show this kind of things. So main memory stores instruction and data of the programs that are running. Main memory content can change during program execution. It's volatile, and it's also called random access memory, RAM. So usually when you buy a computer or you look into the feature of the computer, they'll tell you how much random access memory, RAM, they have. So usually what's the value for it? Maybe there are certain typical values, like 4 gigabyte, 16 gigabyte. So depending on applications, maybe they have some minimum number of value for RAM that needs to be had on the computer in order for you to use that particular application. Main memory consists of a long list of memory locations. So this will be known by byte and also bit, things like that. Okay, so this some terminology about the sizes of memory. So byte contains 8 bits. So that is the number of characters that, or information that can be remembered or stored by that much. Kilobyte will be the symbol is KB. which reminds us of Kota Baru. Kota Baru. Anybody from Newcastle here? Ada orang Kota Baru? Ada. Then megabyte. But nowadays, a lot of stuff in terms of space or drive storage will go into GB or TB. So a lot of memory and also storage will go into this unit, GB and TB. Okay, but if you go into like a bigger size storage for organization, so they'll go into this bigger stuff. All right, data and instructions programs are kept as binary digits in memory locations. So everything will have their own addresses. And so this is where that information will be located. So when the computer needs to recall this information, so they need to know where the address of that information. So they need to know how to get it back. Okay. All right. So a lot of this kind of stuff, but I guess for us engineers, mechanical engineers especially, I do not want to bog down with those kind of things. How about this CPU stuff? So basically, the CPU is the brain. So we need to have brain. We human also need to have brain. So that's why we need to always think about what is good for us. So central, the control unit. So CPU will consist of several stuff, namely the control unit, which retrieves, decodes, and execute instruction from RAM. So RAM is the important part. It's not the biggest memory, but it's the memory for instruction. So that's why this part is important. So a lot of quick stuff, quick action needs to run from the space in RAM, in the random access. So meaning the information can be accessed very randomly at any time. And coordinates activities of all parts of the computer. So in the CPU, we have the control unit. And also we have the ALU, arithmetic and logic unit. So that is also another part for CPU. Hardware optimized for high-speed numeric calculation. Sometimes you can hear the computer doing the calculation. So for harder problems, maybe you hear a lot more activities, a lot more sound. Sometimes that makes you worried what's happening there. And then hardware designed for true or false, which is for logic. True and false is maybe a bit easier. So CPU has those two units, and they work hand in hand. A lot of stuff will need calculation, so that's why this part, but it's separate stuff. So and then we have secondary storage. So this is a lot of the data will be stored there. A lot of data will be stored here. So if you have file for this subject or for some other course, so those will be stored in this non-RAM. So this is not the RAM part. So data is preserved when program is not running or computer is turned off. So it's non-volatile data. Comes in variety of media. So this can be FDD, floppy disk, hard disk, HDD. So nowadays we do not have floppy disk anymore. Magnetic tape, so those are ancient stuff. But we still have the HDD lah, hard disk drive. Optical compact disk. Have you guys seen CD or DVD? Maybe your father, mother will be familiar with this kind of things. And then, but for you guys, I guess this is the generation that we use USB flash. I think this has been the practice for the past 20, 30 years ago. And but nowadays we have the cloud. The cloud, many things are stored in the cloud. The problem is the cloud is probably you have to pay for it. It's not really free. Maybe free only for certain size or certain time. Beyond that, you have to pay, and maybe you can also lose your access to it if not careful. But even for your USB flash drive, you can also lose your stuff, and maybe you forgot to take it from the computer, shared computer, so lost, or maybe somebody intentionally steal it. So input device how to get the information into the computer so that the program can integrate. Okay, so input device will consist of a program and also data. Such as a keyboard. So you can use the keyboard to program your computer and also to key in data. Okay, same for your mouse, scanner, digital camera, microphone. So a lot of these things I think we have used. And output device is for you to send out the information from the computer after it has been processed. So this will include computer monitor, printers, projectors, speakers, okay. And also you can also use the drives, So the drive can be for input and also for output. Okay, like you send something, you have you just work on something, some file, maybe your thesis or maybe your assignment. So you save it. So when you save, you send that output to your HDD. All right. Software. Software refers to program that resides and executes electronically on the hardware. Software is divided into two categories: system software and also application software. System software, application software. Okay, so like system software is like OS. Nowadays we all if you use Apple, maybe it's called something else. Now operating system is general, like can be for Windows. We have Windows XP, Windows 95. Nowadays it's Windows. I forgot the current system. So for Apple, they have their own operating system. For other devices like handphone, will have Android. So many things. So this will be the system software, will be the backbone of how the machine will behave. Okay, and then So operating system, most important type of system software, okay? Because in the computer, it cannot be used without this operating system. So this is the backbone and also the main brain for your system, for the computer, for the hardware to operate. So operating system is basically a computer program also, and this dictates how computer functions and communicate, and allocates computer's resources. Maybe will communicate with the power system, communicate in terms of how the RAM is used, how if you have graphic cards, how the graphic cards will play their function, and also response to users' requests in order to run other programs or applications. So this common operating system, DOS, so DOS, VMS, Macintosh, Linux, Windows, Unix. Pernah dengar benda-benda? Okay, maybe for most of us, we are familiar with this thing lah, Windows. Macintosh is for Apple users, Macintosh. Okay, application software is a lot of other stuff, such as we are using Microsoft Teams, so that is an application software. Or we want to do our typing, word processing with Microsoft Word, so that is an application software. We want to do our CAD. Have you guys learned CAD, AutoCAD? So AutoCAD is an application software. So all these things are very useful for specific purposes. And so if you are in banking system, you definitely have your own specific software to be used for that purpose. Okay. Where are the application and system software? So users, application software, system software, hardware. So system software is hardcore that governs or controls around the software. So everything else can access the hardware through the system software. Okay. Programs and programming languages. A computer program is a set of written instruction. So that is part of application software, part of application software, and given to a computer for it to follow. To write a program needs a programming language. Okay, and this programming language, we have a lot of programming languages. Is a buffer or an intermediary between human language and the machine language. If you look on the right side here, you have on the top here is human language, language that you and I are using, either English or Bahasa Melayu, Mandarin, Tamil, Tagalog, Kadazan, or even Hebrew, any Hebrew talkers here. And so the computer program is not really human, but it's close, because we use words such as enter the number or see out. Enter the number is pretty much human language, but see out, that is not really English. The out is English, but see out or count, so that is not in. How about in, but you have C in the front, see in, so that is not human language. And it's not computer language either. So because computer only understand in zeros and ones. Okay. So this is an intermediate between the language that we can talk to we can use to talk to the computer, and the low level machine language that computer will will understand. So somewhere here there's a black box that do the translation. Okay, types of programming language, high level, so C++, MATLAB and things like that, C Sharp. So those are high level programming languages. And we have low level languages that is used to communicate directly to the computer. So that is using zeros one. Okay, so there are some human that can do this low level communication. Maybe in the past this is what people do, but I don't want to go into that history. But some people can do this thing, but for our context or our class, we do not go into that that zone. Okay, do you have any questions so far? Or is it time for you to go to Bazaar Ramadan? It's too early. Awal lagi ya. Kedai belum buka. Dah masak apa tu hari ni? Dia nak buat resepi-resepi. Aku sayang tu. Ayam goreng sedap. Anywho, so back to here, language of computer is the language, machine language. So the low level is called the machine language. So this is very hard for us to do. Like, can you talk in this thing? 1011, what is it? What does that mean? And there's no question mark punctuation at all here. So all in one line, but perhaps it's a code to say launch the missile. I don't know, some kind of instruction there. Okay, so back in the 1940s, when computers started to be used, so it's called machine language. So that's around the time World War II was taking place. So, and then in the 1950s, symbolic languages. So I'm not really sure what that is. Maybe they use symbols. So back in the machine language will be zeros and ones. Symbolic maybe some, I guess, symbols or icons. And in the 1960s, a lot of computer programming, even CAD, a lot of those kind of things take place in the 1960s. I guess a lot of engineering good engineering achievements in humanity occurred in 1960s, like computer modeling, computer ANSYS, even AutoCAD started during this time, 1960s and also 1970s. It is the time during the Cold War and also the race for space, moon landing, things like that. You think moon landing happened? Ada siapa nak pergi ke bulan? Okay, and then when we get to 1990s, natural languages evolving. I guess high-level languages like C, C++. They started in this era, and then when you get to 1980s and 1990s, easier languages start to evolve. So this will be making the the programming much easier for human. But get to our times, for the past few years, we have another revolution or another leap with AI. So we have a lot of people say, you don't have to code anymore. You don't have to learn programming anymore. You can just give code or type prompts. So it's about getting the right prompts to do your bit. Okay. What do you think? You think this AI thing is going to last long, or is it going to? What do you think? Do you folks use a lot of AI?
Betul, sir. Senang.
Senang, Senang. Okay. The only language understood by computer is machine language. Okay. So I guess doesn't matter whether you use high-level natural language or AI nowadays, but when it gets back to the computer, they will use machine language. So that's the only language that the computer understand, zeros and ones. Okay. Okay, I'm not going to read this kind of things. It's not really helping us. But I think if you sebelum buka puasa, after you do your doa and things like that, your prayer, ask for good grades, good friends, good future. You can also read this kind of things if you have the time to understand more. Symbolic assembly. Oh, symbolic is called assembly language. Yeah, I've heard of assembly language, but still, it's not something that. Okay, so symbolic languages with this kind of things like load, mount, store. So it's a building block for us to get into the high level things. So when I was a student, I used Fortran, and also Pascal. For my masters, I think I use either C or C++. So that's why I was selected to teach you guys C++. But actually, when I did my PhD, is more on using MATLAB. MATLAB is based on C++, but it's much easier. But it's not AI. Still need to do the coding. Okay, and so a lot of others, the rest are pretty much some history. So C++, since we are using C++ as our tool or as our programming language, so it was created by Björn Strostrup. Sounds Scandinavian or German, but he was working at Bell Laboratories. I guess Bell Laboratories is an American company. So maybe at that time, C programming language was commonly used, but Björn made some modification and make it become C++. So it's not C++, but C++. So maybe a lot of things or shortcomings was improved or upgraded. So basically, he incorporated object-oriented programming. So object-oriented programming is something, a term. I commonly heard that, but something that you need to go through. Where C, it is still based on the original C, but it has some differences. Maybe we can look into that next time. But C++ program were not always portable from one to compiler to another. By mid-1998, NC, ISO, C++ language standards were approved. So I guess the compiler is also another thing. Compiler is like the heart of, or the heart or the brain of the application software. So like the operating system is the brain for the computer, but the compiler is the brain for the programming language, or for the programming language, or for any application. So the compiler can be many. Even for C++, they can have many compilers. In the past, it was like that. But so if you do your programming in Kedah using certain compiler, then you come back to Malacca, we have another compiler in our machine. So your programming C++, even though it's same C++, but because of the difference in compiler, it might not be compatible. So that is what it's trying to say. But all this thing was rectified when they have some standardization, and then pretty much you can use your C++ program on any compiler. So this is a snapshot of kind of like introduction of what the coding should look like. So it's like include IO stream. So, and then using namespace std. So this, my friends, is the part that you need to always remember for the rest of this semester lah, at least. Hopefully you can also use it for other courses. But for at least this class, this is something that you need to remember lah. If you don't remember anything else, remember this. So always start your line, your code with hashtag include IOStream in the pointy bracket, and then this instruction using namespace std or standard, and semicolon. Semicolon is very important to end the sentence or the line. But not everything. Like the first line here, you do not have the semicolon. Okay, and then in is usually for integer, main, and then the brackets or parentheses, and then we have this squiggly bracket or curly bracket to open and to close. And before you close it, you have to have this return 0. But this is actually optional, sunat. But in some other situation, you need to have this thing. Okay, so this is another example. Include IOStream, okay, using namespace standard. And then you have this thing, my first C++ program, ENDL. ENDL is for end of line. And then after ENDL, it will go kind of like enter into the next line. So then C out, then the statement, the sum of 2 and 3 is 5. Okay, ENDL. All right. Just before we finish this thing, let's try to let me stop sharing for a bit and try to open another window. Okay. Okay. How to get back to share this thing? Okay. Okay. In Newland, I guess I shared a couple of tools that you can use. So there are three tools. One is this thing called Programmis. I guess you can search, Google Programmis C++. So this is an online compiler. So another one is called C++ Shell. C++ Shell. So that's another good item to use. But the layout is a bit different from this one. And then the last one is a dev C++. There are other things. Maybe some other things you need to pay for it, or maybe the size of the application is so big. But dev C++ portable is very useful. Maybe in the lab I will show you, or maybe next week I will show you how to use it. But it's pretty much the same if you use in any compiler for the most part. So let's take a look here. When you open these online tools, usually they already have some ready-made program for you to test run. So if I hit run, I'll show you the output on the either the right side or at the bottom. So this is the basic stuff that is shown there. So if I go ahead and copy this thing, copy it, and replace this thing up to there, paste. Control Z. Let me paste it down here. I want you to notice some differences here on the basic strategy. So we can have empty space. So empty space, they will not read. So there's nothing. You can delete empty space if we can do that. So see here, if we do not have this line using namespace std, you have to do this kind of things. So instead of just C out, so you have to do std colon C out. So it'll make your so this is kind of like command. So it'll make the command long. Okay. So if you already have this using namespace std, so you do not have to do std in every command that you want to use. Okay. So if you want to comment that out, you can use either // or slash star, and then up to here star slash. So meaning here I'm commenting this thing out. So the computer will not read this instruction. It's still there. So this is good for you to have comments or write notes, things like that. So like here I want to have a note. So this avoids having to repeat STD all the time. Yeah. So that is so the computer will not, you see this, but the computer do not read this thing. So it's not an instruction there, just for you to read, to help you understand the program, the code. So let's hit this run here and see what the output is. So see out is just printing out or presenting whatever is in the what call that quotation mark. So if you write whatever here, my first C++ program, so just spit that out. Okay, so after ENDL, it'll go down another one line. So in the new line, you'll write sum of 2 and 3, which is here, sum of 2 and 3 equals 5. So we directly put 5. We do the calculation for the program. And the third one, so ENDL will go to the next line. So the third one is this thing, 7 plus 8 equals. So here we want the computer to do the calculation for us. So we don't want to be the one to do the calculation. So here, if I put here 2 plus 3, or change this to 2 plus 5. So change it to 2 plus 5. So computer will do the calculation. Now that is 7. 7. So so are you guys having enough fun for today?
Pening doktor.
Pening? Ya, pening. Makan ubat. Nah, bukan sekarang lah. Buka puasa nanti makan ubat. Yeah, I think this is something new for a lot of new students. You guys tahun 1 ya? So tahun 1 I guess is new, but I think even though you do not use computer programming that much in your studies or in your career in the future, but maybe a little bit of programming is needed. Trust me, because I have been a lecturer for a long time. Sometimes you cannot avoid from doing a little bit of programming in your career or in your studies. Maybe in second year you have to take this thing called microprocessor or microprocessing technology. So that one you have to do project using some circuits, some motors and things like that. So in order to have this machine function properly, you need to code it. Might not be C++, might be something else, but the thing is coding. So you still need to code it. Okay, and AI is good, but AI is still in its infancy, still bertatih-tatih. So not everything can be AI. But sure, even if you AI it, sometimes it doesn't work properly. So that's why we need to understand the basics of coding, so that whatever screw up AI is giving you, you can fix it. You know where to fix. Where is the possible places for the problems. Okay, thank you for coming to the class. I guess it's a good place to stop. There'll be no class on Thursday, but I will put something on ULearn, so do check it out. Maybe after I upload that, message will be sent out to you, and if you have the time, please check it out. So other than that, you guys have a pleasant Aidil Fitri, and stay safe. Be vigilant, and inshallah I'll see you guys next week on Tuesday. Oh, no Monday class. No Monday class. I guess it's an off day on Monday, but I will put something on ULearn anyways, so you can check it out there. Actually, like this is the third time I'm teaching this class, so I have a lot of videos I already made from the past, so I'll put them out on ULearn. So you guys check out ULearn from time to time. Thank you for coming again. You guys have pleasant breakfast, iftar later on, and not now. Jangan buka puasa Muhammad Amirul Hafiz, bukan sekarang. Okay, inshallah I'll see you guys when the time comes. Assalamualaikum. Have a good one. Bye-bye.
Waalaikumsalam. Terima kasih, Doktor.
Thank you,
Waalaikumsalam.
Doctor.
Thank you, Doctor.
Okay,
Thank you,
welcome.
Doctor.
Bye-bye.
Thank you, Doctor.
Okay, welcome.